stop. Have you ever wondered how do we know if buildings will stand an earthquake and other soil-related activities? Is it because of the NAIA? Maybe, but definitely no. Is it because of the experts? But in this video, we will be focusing on geotechnical engineers. Geotechnical engineers play an important role in safeguarding structures and communities from the challenges posed by earthquakes and landslides. In terms of earthquakes, their expertise is crucial in assessing seismic risks and designing resilient foundations. But first things first, what is geotechnical engineering?
Geotechnical engineering is the study of how soil behaves under different forces and how they interact with water. Some branches of geoengineering are: number 1, rock mechanics, of course, focuses on rocks. Number 2, foundation engineering. Integrates this with structural engineering to design foundation. Lastly, soil mechanics. Studies how soil property and behavior in essence. It's all about understanding engineering properties of earth materials. In short, geotechnical engineering transforms our understanding of earth materials into practical solution, ensuring that our infrastructure is safe, stable, and sustainable. Since we are talking about earthquakes, geotechnical engineers identify and mitigate hazards like earthquake. They come up with strategies such as slope stabilization and drainage system. They analyze soil condition to understand how structure will react to seismic forces and incorporate seismic design criteria in their plans. This includes upgrading existing buildings and provide safety warnings in order for us to be safe and prevent accidents. You think that's all? How about we dig deeper?
Don't stop. Go on.
Analysis and design. Geotechnical engineers analyze data to assess designing foundations and structures to ensure long-term safety and performance. Foundation design.
Oops, wrong one. Hold on, that's right. They determine the most appropriate foundation type based on soil conditions and load requirements, ensuring it meets settlement and bearing capacity limits.
Construction support. During construction, engineer reviews plans, monitor activities, and inspect compliance, addressing any unforeseen geotechnical issues. Reporting, writing, and documentation. They prepare detailed reports summarizing findings and recommendations, essential for communicating with project stakeholders. Collaboration and communication. Effective communication with other professionals ensure geotechnical considerations are integrated into the overall project design and execution. Role in civil engineering projects. Geotechnical engineers are crucial in projects involving roads, railways, and foundations, ensuring ground condition support, construction, and mitigating natural hazards impacts.
Kuya, bilis saldo.
So, how much do you think a geotechnical engineer salary is?
I think around 28,000 pesos.
Okay. Okay. Hello. For my question is, how much do you think a geotechnical engineer salary is?
Mga nasa mga 70k, so 80.
Okay, that's a good guess. At least you think that geotechnical engineers are valued and they have a high salary pay. Thank you very much.
So, hello ate. My name is Crizel and today I'm going to interview you. So, how much do you think the salary of geotechnical engineering is?
Geotechnical engineering, my guess is at around 25 to 30k.
Oh, so that's a great guess. Thank you.
Thank you.
So, good afternoon, Kuya. So, how much do you think geotechnical engineers salary is?
About 100,000.
That's a good guess. Thank you.
So, hello, good afternoon. So, I just have one question. How much do you think a geotechnical engineer's salary is?
50,000.
70,000.
Okay. Very good guesses. Thank you very much. Thank you.
All guesses are good, but the average salary of geotechnical engineers in the Philippines is 48,463 pesos as of August 12, 2024. Now that we briefly talk about the function and geotechnical engineering, let's now explore its history. Do you have any idea who is the first geotechnical engineer? It's Carl von Terzaghi.
It's a very honor. I feel like I am the first honor.
He was an Austrian engineer known as the father of soil mechanics. He pioneered the study of soil behavior and its impact on engineering structures, significantly advancing the field with his development of the concept of effectiveness stress and contributions to foundation design and slope stability. His work laid the foundation for modern geotechnical engineering. Now, let us explore the history of geotechnical and how its methods evolved over time. First, activities concerning this branch of engineering were linked to ancient construction of irrigation and flood control systems in Egypt, Mesopotamia, Greece, Rome, and many more. Structures in Egypt, such as the Egyptian pyramid, were made from stone and mud bricks, and the Nile River irrigation system that still provides water to Egyptian farmers until this day. French royal engineer Henri Gautier noticed the natural slope of different types of soil in 1717, which is now known as the soil's angle of repose. This is the special intern friction angle, then the development of rudimentary soil classification system. Geotechnical engineering mechanics started when Charles Coulomb introduced mechanics in solving soil problems in 1773, combining his theory with the theory of a 2D stress plate of Christian Otto Moore. The Moore-Coulomb theory was born and is useful up to the present time. In ancient times, as mentioned earlier, Egypt has many structures that are very remarkable and are still usable. However, Egypt wasn't the only civilization that came up with engineering marvels that are still considered to be great in these times. Ancient Greece were known for their bridges that transported water from springs to cities. This was later on adapted and copied by the Romans. Rome built the Segovia aqueduct and roads that still exist until this day.
It was my turn! You told me it was my turn!
In medieval times, an example of a structure built during the medieval period is the Tower of London. This structure will stand still today because of its effective and strong foundations built with the materials available to the civilizations at that time. This is the proof that proper engineering and application is very crucial and will last long period of time. In modern era, during the Renaissance, advancements were made by the civil engineers such as Leonardo da Vinci, who designed innovative machines. Geotechnical engineering advancements were developed later. During the Industrial Revolution leading into the 19th century, geotechnical advancements were made such as the construction of larger-scale waterways and bridges. In the 1930s, during the 20th century, the Hoover Dam in the USA was constructed after several attempts. The construction was a major achievement in civil engineering as it became the largest cemented structure in the world. Today, the dam provides electricity to many cities. One of the famous tourist spots nowadays is the Leaning Tower of Pisa. But do you know why it is leaning? And what actions have been taken to prevent it falling?
The leaning of the Leaning Tower of Pisa was due to the strength of the soil where the structure was constructed. Generally speaking, it was because of poor or lacking geotechnical precautions and soil testing.
So, when geotechnical engineers realized their mistake, they had to add counterweights to stop the leaning and maintain its form. This precaution proved to be effective because, as well, all no tourists are visiting this structure.
This research proved that engineers from the ancient times to the present time are evolving and are getting knowledge to build more sustainable structures that will stand through centuries to come.
Geotechnical advancements such as studying the soil and their slopes have proven useful and effective. And together with the technological advancements, testing and readings have been easier and faster.
Blah, blah, blah. Enough with the past. Moving
Move
on.
Professional conduct of geographic engineers who specialize in applying engineering concepts to address geography-related challenges is guided by various ethical obligations. These obligations make sure that their work upholds the professional standards, respect the environment, and help society. Public welfare and safety. Geographical engineers have a responsibility to put the public health, safety, and welfare first in whatever they do. Creating projects with the fewest possible dangers to the public and environment is part of this. For instance, a geographical engineer working on a dam construction project makes sure the dam is built to resist possible natural calamities like earthquakes or floods. In order to protect the local communities' safety, they must also take into account the impact on such communities. Ecology rules. Geographical engineers have a responsibility to reduce their negative effects on the environment and advance sustainable development. When making designs and judgment, they ought to take long-term effects on the environment into account. As an illustration engineer, geographical engineer evaluates the possible effects on nearby ecosystems when designing a new roadway by rerouting a route to avoid vulnerable areas, including animal corridors. They assist safeguard the environment while still accomplishing the project goals. Honesty and integrity. Engineers have a responsibility to uphold honesty and integrity. In their professional endeavors, they should refrain from deceiving stakeholders, give correct information. For instance, even it means postponing the project, adding to the expenses, or geographical engineer has the obligation to notify project managers and stakeholders of the possibility of landslides at a planned construction site. It would be unethical to withhold such information, and doing so might have disastrous results. Come, take a walk with me. Responsibilities and expertise. Accountability. Geographical engineers should be accountable for their choices and actions, making sure that their work complies with ethical professionals' norms. Example, a geographical into the reason behind a construction failure. If they made a mistake in their work, they caused the failure. They should own up to it and make the necessary corrections instead than blaming others or refusing to take accountability. Respect towards social and cultural values. Engineers have a responsibility to honor the social and cultural norms of the community. When they work, they ought to interact with the community and take into account in wants and words. Example, a geographical engineer collaborates closely with the indigenous population to ensure that development preserves their cultural heritage when developing land in a region with major indigenous cultural sites. This could entail modifying the project's designs to protect holy locations or offering substitutes that are advantageous to the project as well as the community. Ongoing education and efficiency. It is the responsibility of a geographic engineer to keep up and advance their technical expertise. They ought to implement the best development in their industry and engineer employed regions vulnerable to the effects like a coastal erosion that would regularly keep up with the latest developments in modeling methodologies and mitigation approaches. This guarantees that they are working with the newest and most efficient techniques possible, openness and correspondence, accountability, and critical communication, effectively with all the parties involved, including clients, the general public, and regulatory agencies. Engineers need to be open and honest about their research procedures, conclusions, and possible repercussions. It is great ethical duty of a geographic engineer to strike a balance in between the needs of development and the preservation of the environment and the welfare of society. They support ethical and sustainable development that benefits the present and future generation by upholding these moral precepts and putting them into the use of practical situations. In the Philippines, the first notable geotechnical engineer is often recognized as Dr. Alfredo M. Velasco. Being the pioneer in the field, he made contributions in developing soil mechanics and foundation engineering. His work laid the groundwork for modern geotechnical engineers in the Philippines. Our country is located in a region known as the Pacific Ring of Fire. Uy, psst, asa mo ka nagtanaw? Tara, okay. It is home to about 75% of the world's active volcanoes and frequent earthquakes. This is due to the movement of tectonic plates in this area. This explains why pH is so frequently affected in earthquakes and volcanic eruptions. Speaking of which, the 2018 Itagon landslide, a catastrophic landslide in Itagon, Benguet, during Typhoon Ompong caused significant loss of life and damage. The disaster emphasized the need for geotechnical assessment in slope stability and landslide risk management.
Sa kung pangatana karon, unsa na to ni pag-end?
Pag-transition sa
Like gusto ko ang ending nato is kanang remarkable good na kanang murag ano siya, impactful nga ending. Wait lang.
Ipakita si Danaya.
Ayun. Wait lang.
Don't wanna know